economical power controlled by a snappy governor with uncanny ability.
Before the Massey Ferguson 35 existed, the problem on small and medium farms was not a lack of ambition, but a lack of workable time. In the late 1940s and early 1950s, millions of farms across Europe, North America and parts of the Commonwealth still relied on horses, aging pre-war tractors or improvised machinery. Fields were smaller, labor was family-based, and seasonal windows were unforgiving. Planting late or harvesting slow did not reduce comfort, it reduced survival. Farmers could plow, seed and hoe, but rarely at the pace demanded by modern markets. Livestock chores competed directly with fieldwork. One machine was often expected to do everything, yet most tractors were built for a single role. Larger row crop tractors delivered power, but demanded wide fields, strong soils, and capital many farms simply did not have. Smaller machines existed, but they were often underpowered, mechanically crude, or limited by rigid designs that assumed ideal conditions. Labor shortages intensified the pressure. Post-war reconstruction pulled workers into factories and cities. On many farms, one operator replaced 3 or 4 hands. That meant longer days, higher fatigue, and little margin for mechanical failure. When a machine broke, there was no backup. Repairs happened in the field, with basic tools, because downtime translated directly into lost yield. The core problem was not horsepower alone. It was balance. Farmers needed traction without excessive weight, versatility without complexity, and reliability without specialized service. They needed a tractor that could plow in the morning, cultivate in the afternoon, and pull a trailer at night, all while remaining affordable to buy and cheap to maintain. Existing systems could not solve this contradiction. Horses were flexible but slow. Large tractors were powerful but impractical. Small tractors were economical but limiting. The gap between these options defined daily farm life.
For many operators, progress meant improvisation. Implements were modified, workloads stretched, and maintenance schedules ignored. Efficiency gains came from endurance, not technology. The farm system functioned, but only barely, and every season exposed the same weakness. Without a truly adaptable tractor, growth was constrained by human limits rather than land. It was within this unresolved tension that engineers at Massey Ferguson began to rethink what a general-purpose tractor actually needed to be.
By the early 1950s, the shortcomings of existing tractors were no longer just an inconvenience. They were a structural limit on how farms could evolve. Across many regions, farmers were trying to modernize without abandoning their mixed agricultural systems. That meant one machine still had to handle plowing, cultivating, mowing, hauling, and stationary power tasks like running pumps or threshers. Most tractors on the market simply were not designed with that level of versatility in mind. A common issue was specialization. Some tractors were optimized for row crops, with narrow front ends and high ground clearance, but they became unstable or awkward in heavy pulling tasks. Others were built as utility machines, compact and simple, but they lacked the hydraulic capability and torque stability needed for demanding fieldwork. These forced farmers into compromises, either own multiple machines or accept inefficiency. Cost was another barrier. Post-war agricultural equipment prices were rising, while farm incomes remained volatile. Even when credit was available, investing in multiple tractors was unrealistic for smallholders. Maintenance infrastructure also lagged behind. Rural workshops could repair engines and basic drivetrains, but more complex systems increased downtime and dependency on factory parts. Engine technology of the time was improving, but integration lagged behind. A tractor might have adequate horsepower on paper, yet poor weight distribution or inefficient transmission meant that power never fully reached the ground. Slippage, fuel waste, and mechanical strain reduced real-world performance. Farmers measured success not in specifications, but in acres completed per day under real soil conditions. There was also a growing awareness that tractors needed to be intuitive. Many operators were transitioning from horses directly to machinery without formal mechanical training.
Controls that were too complex reduced productivity rather than improving it. Simplicity, therefore, was not a design flaw. It was a requirement. In this environment, engineers working within Massey Ferguson began to explore a different philosophy. Instead of building specialized machines for narrow roles, they considered a single platform that could adapt through attachments and balanced engineering. The goal was not to maximize one performance metric, but to achieve dependable all-round capability at a price that matched small and mid-sized farms. This shift in thinking set the stage for a tractor that would not just replace existing machines, but redefine what general purpose actually meant in practice. The idea behind the Massey Ferguson 35 did not appear as a single breakthrough moment, but as a response to a persistent industrial gap. By the mid-1950s, agricultural demand was shifting faster than tractor design cycles. Farms were expanding in efficiency expectations, not necessarily in size, and that meant every machine needed to deliver more output per hour without increasing operational complexity. The core problem engineers were trying to solve was imbalance between power, weight, and usability. Many tractors of the period either delivered adequate engine performance but suffered from poor traction efficiency, or they were mechanically simple but lacked the hydraulic and PTO capabilities needed for modern implements. This created a bottleneck in farm productivity. Implements were improving, but tractors were not keeping pace in integration. Fuel efficiency was also becoming a concern. Diesel engines were increasingly preferred in agricultural use because of their torque characteristics and lower operating cost compared to gasoline engines. But not all tractors were optimized to take advantage of that advantage. Poor gearing and inefficient drivetrain layouts meant that engine potential was often lost before reaching the wheels or the power takeoff shaft. Another pressure point was standardization. Farmers were increasingly expected to use interchangeable implements across different tasks. That required consistent hydraulic performance, reliable hitch systems, and stable power delivery. Without standardization, every attachment became a custom problem, increasing downtime and mechanical uncertainty. Within this context, engineers at Massey Ferguson focused on a design philosophy built around balance rather than extremes. Instead of building a high-power specialist machine, the goal shifted toward a mid-range tractor that could perform most farm tasks competently without requiring constant adjustment or multiple configurations. The emerging concept prioritized simplicity in control layout, mechanical accessibility for field repairs, and a chassis capable of supporting varied workloads without structural stress. This was not about creating the most powerful tractor of its time, but about creating one that could be used all day, every day, across different tasks without breaking operational flow. This shift marked the beginning of what would become the Massey Ferguson 35, a machine designed not for one perfect job, but for the reality of mixed farming systems that dominated global agriculture at the time. When the Massey Ferguson 35 moved from concept toward production reality, its appearance immediately set it apart from many tractors of the mid-1950s. At a time when agricultural machinery often emphasized bulky frames and visually aggressive proportions, this machine adopted a more compact and restrained form. To experienced farmers, it did not look like a breakthrough at first glance. In fact, some considered it too small, too simple, or even underbuilt for serious fieldwork. The visual simplicity came from deliberate engineering choices. Instead of hiding complexity behind heavy external structures, designers at Massey Ferguson concentrated systems into a tighter, more functional layout. The engine, transmission, and operator position were arranged to reduce unnecessary distance and mechanical loss. This gave the tractor a balanced stance, but also made it appear less imposing than competing machines of similar capability. The front-end design reflected practicality over tradition. Many tractors of the era still carried design cues inherited from earlier models, including oversized sheet metal and rigid styling meant to convey strength. The MF35 moved away from that language. Its structure prioritized visibility and accessibility. Operators could see the front wheels clearly, which was important for precision work in tight field rows and when operating mounted implements. Another unusual aspect was its proportional weight distribution. Rather than concentrating mass in a single section, the tractor spread its load to improve traction consistency. This reduced wheel slip under moderate field conditions and helped maintain stability when using mounted equipment. To farmers accustomed to heavier, front-loaded machines, this felt unconventional, even slightly fragile at first inspection. However, the design also reflected a growing understanding of operator fatigue. The seating position was aligned to reduce vibration exposure and improve control reach.
Controls were placed within a compact ergonomic range, minimizing unnecessary movement during long working hours. These choices were not immediately obvious in photographs or showroom appearances, but they became important in daily use. In many ways, the tractor's incorrect appearance was a consequence of rejecting outdated assumptions about what a farm machine should look like. Instead of projecting power visually, it prioritized functional efficiency in real working conditions. This tension between appearance and performance would define early reactions to the machine once it reached farms. Under the outer simplicity of the Massey Ferguson 35 was a deliberately balanced technical package built for mixed agricultural work rather than specialization. At its core sat a small-capacity diesel engine, typically in the low to mid 30 horsepower range, depending on configuration and market. This level of output placed it firmly in the utility tractor category of the late 1950s and early 1960s, where versatility mattered more than raw power. The engine itself followed the common agricultural diesel principles of the era: low-speed torque delivery, mechanical fuel injection, and a focus on durability under continuous load. It was not designed for high-speed transport or racing performance, but for sustained pulling force at moderate RPM. This allowed the tractor to maintain steady operation in plowing, cultivating, and hauling tasks without excessive fuel consumption. Power transfer was handled through a manual gearbox with multiple forward speeds and at least one reverse range, a standard but essential feature for adapting to different soil conditions and implement loads. Gear spacing was not simply about speed variation. It was about keeping the engine within an efficient torque band. Poor gear selection could still reduce performance, but the range available gave operators flexibility across field types. A key technical feature was the inclusion of a rear power takeoff system, which allowed the tractor to drive external implements such as mowers, balers, and pumps. This transformed the machine from a pure traction unit into a mobile power source, significantly expanding its usefulness on mixed farms. In practical terms, it meant one tractor could replace several stationary engines or animal-driven systems. Hydraulic capability was another important part of the design. The three-point hitch system, widely adopted across the industry, allowed implements to be mounted and controlled directly from the tractor. On the MF35, this system was engineered for reliability rather than complexity. It did not aim to be the most powerful hydraulic setup of its time, but it was consistent enough for daily agricultural tasks. Weight distribution and chassis strength were tuned to avoid overloading the drivetrain during typical workloads. Engineers at Massey Ferguson focused on preventing failure points rather than maximizing theoretical output. The result was a machine that operated within predictable mechanical limits, which was critical for farms without advanced repair infrastructure. Overall, the technical identity of the MF35 was defined by moderation: enough power to be useful, enough simplicity to be repairable, and enough adaptability to replace multiple older systems without overwhelming the operator. The first real-world introductions of the Massey Ferguson 35 did not happen in dramatic launches or large industrial exhibitions alone, but quietly, through dealerships and local distributors supplying working farms. In many regions, small and medium-sized farmers were the first to encounter the machine, often as a replacement for aging pre-war tractors or teams of horses
that were becoming increasingly unsustainable. Initial reactions were cautious. The tractor's compact size and relatively modest engine output led some operators to underestimate its capability. On paper, it did not appear dramatically different from other utility tractors of its class. However, farmers evaluated machines differently than engineers. They looked at fuel use, ease of starting, reliability under load, and whether the machine could complete a full day without mechanical interruption. Early adopters quickly put it through practical tasks: plowing clay soils, pulling loaded trailers, operating stationary equipment, and running field implements across uneven terrain. In these conditions, the design decisions made by engineers at Massey Ferguson began to show their value. The tractor's balanced weight distribution and steady torque delivery allowed it to maintain traction where some heavier machines struggled with wheel slip or inefficient power transfer. Operators also noticed the simplicity of controls. Many farmers transitioning from horses or older mechanical systems valued predictability over complexity. Starting procedures, gear selection, and implement handling were straightforward enough that learning curves were short. This mattered in rural environments where formal training was rare and machines had to be understood through daily use rather than manuals alone. Fuel consumption became another early point of discussion. While exact values varied by region and workload, the general perception was that the tractor delivered reasonable efficiency for its class. In practical farming terms, this meant longer working hours per tank and reduced operating costs compared to older, less optimized equipment. Not every reaction was immediately positive. Some operators expected more raw pulling power based on its size and initially pushed it beyond typical working limits. In overloaded conditions, like any tractor of its category, performance declined. However, within recommended use, reliability remained consistent, which gradually shifted opinion from skepticism to trust. These early field experiences formed the foundation of its reputation. It was not a machine that impressed through spectacle, but one that earned acceptance through repetition of successful daily work under real agricultural conditions. Once the Massey Ferguson 35 entered continuous field use, its true character was defined not in controlled demonstrations, but in the variability of real agricultural environments. Farms are not uniform systems. They include wet ground in spring, ardent soil in summer droughts, uneven terrain, and workloads that shift daily between traction, transport, and stationary power. The tractor had to operate across all of these without interruption. In plowing operations, the machine showed consistent behavior when matched with appropriately sized implements. Its moderate weight helped maintain traction without excessive soil compaction, which became increasingly important as agronomic awareness grew. On heavier soils, performance depended heavily on correct gear selection and operator skill, but within its intended range, it maintained steady forward progress without frequent stalling. In transport tasks, the tractor was commonly used to pull trailers loaded with crops, feed, or materials between fields and storage areas. Here, stability and braking behavior mattered as much as engine output. The compact wheelbase and balanced structure allowed it to remain controllable on uneven rural roads, although, like many tractors of its era, it was not designed for high-speed travel. Stationary work highlighted another dimension of its versatility. Through its rear power takeoff system, the MF-35 could drive equipment such as threshers, pumps, and generators. These reduced dependence on separate engines, which were previously required for many farm processes. In regions with limited infrastructure, these capabilities significantly improved operational independence. Environmental conditions also tested the machine. Mud, dust, and temperature variation exposed weaknesses in less robust designs of the period. The MF-35 was not immune to wear, but its mechanical layout allowed relatively straightforward maintenance. Components were accessible enough that many repairs could be performed in field with basic tools, an important factor in remote agricultural areas. Operators learned quickly that success with the tractor depended on understanding its limits. Overloading attachments or ignoring gear suitability led to reduced efficiency and mechanical strain. However, when used within its intended envelope, the machine demonstrated a level of consistency that reduced uncertainty in daily planning. Across different regions and farming systems, the same pattern emerged. The tractor did not dominate through extreme performance, but through dependable repetition. That reliability under varied conditions became its most valued operational trait. As the Massey Ferguson 35 proved itself in day-to-day farm work, its reputation began to spread beyond individual fields and local dealerships into broader agricultural markets. This transition from early adoption to mass acceptance did not happen instantly. It was the result of repeated demonstrations of reliability under real economic pressure, where downtime, fuel costs, and labor shortages directly influenced profitability. Manufacturing scale increased as demand expanded across multiple regions, particularly in Europe and Commonwealth markets, where mixed farming systems were still dominant. The design's adaptability made it suitable for a wide range of climates and soil conditions, reducing the need for region-specific variants. This manufacturing efficiency helped lower production complexity and supported wider distribution. Dealers and agricultural suppliers began to recognize a pattern. Farmers were not returning the MF35 due to dissatisfaction. Instead, they were often purchasing additional units for expanding operations or replacing older equipment entirely. This behavior indicated a shift from experimental use to structural adoption within farm fleets. One of the key drivers of mass adoption was its role as a single tractor solution. Many small and medium farms could not justify owning multiple specialized machines. The MF35, within its power range, could handle plowing, cultivation, mowing, transport, and stationary tasks. While it was not the most powerful machine in any single category, its combined capability reduced the need for equipment diversification. At the same time, agricultural mechanization was accelerating globally. Labor migration from rural areas to urban industries created persistent workforce shortages on farms. This structural change meant that machines like the MF35 were no longer optional productivity tools, but essential replacements for human and animal labor. Maintenance infrastructure also matured alongside its spread. Spare parts availability improved, and mechanics became more familiar with its systems. Because the tractor was mechanically straightforward compared to more complex competitors, repair times remained relatively short, which reinforced its economic appeal. Within Massey Ferguson, the success of this model contributed to a broader design direction focused on modularity and usability rather than raw specification growth. The MF35 became a reference point for how a balanced utility tractor could perform across global markets without losing accessibility. By the time production and distribution reached their peak, the tractor was no longer just a product. It had become a standardized tool in modernizing agriculture across multiple continents. As the Massey Ferguson 35 became firmly established in global agricultural markets, its influence began to extend beyond individual farms into broader economic and structural changes in rural production systems. The tractor was not just replacing older machines. It was altering how labor, time, and land efficiency were calculated in everyday farming decisions. One of the most immediate impacts was on labor allocation. In regions where mixed farming dominated, a single operator equipped with a utility tractor could perform tasks that previously required multiple workers and animal teams. This did not eliminate agricultural labor entirely, but it restructured it. Human effort shifted from repetitive physical work to machine operation, maintenance, and planning. This change had direct economic consequences. Farms that adopted mechanization through machines like the MF35 could expand cultivated area without proportional increases in labor costs. That shift improved productivity per worker, a key metric in agricultural industrialization. Over time, this contributed to consolidation trends where smaller farms either modernized or merged to remain competitive. Fuel-based mechanization also influenced supply chains. Demand for diesel fuel, spare parts, and mechanical services increased in rural economies. These created secondary industries around agriculture, including repair workshops, dealership networks, and equipment logistics. In many regions, tractors became central not only to farming, but to rural economic infrastructure itself. From a production standpoint, the MF35 helped standardize expectations for what a utility tractor should deliver. It demonstrated that mid-range horsepower, when combined with balanced design and reliable hydraulics, could cover a wide spectrum of agricultural tasks without requiring specialization. This influenced competitor designs and encouraged a broader shift toward multi-purpose agricultural platforms. Within Massey Ferguson, the success of this model reinforced the commercial viability of designing for usability and versatility rather than extreme performance metrics. Other manufacturers observed that farmers valued consistency, low maintenance requirements, and adaptability more than marginal increases in horsepower. Globally, the tractor spread contributed to increased agricultural output stability. While it was not the sole factor in improving food production, it played a role in reducing variability caused by labor shortages and inefficient tools. In many regions, mechanization reduced the time between planting and harvesting operations, which helped improve yield reliability under changing weather conditions. The broader legacy of the MF35 is therefore not defined by a single technical breakthrough, but by its role in accelerating a systemic shift toward mechanized, scalable, and economically efficient farming practices. Years after its introduction, the Massey Ferguson 35 can still be traced in working condition on farms across multiple continents, often long after newer and more powerful tractors have entered the market. Its continued presence is not the result of nostalgia, but of mechanical practicality. Machines that were designed for simple maintenance and balanced workloads tend to survive longer in environments where full industrial service support is not always available. On many farms, the MF35 gradually shifted roles. As larger tractors took over heavy-duty plowing and high-capacity transport, the smaller utility tractor often remained in daily use for secondary but constant tasks. These included light cultivation, livestock feeding operations, yard work, and equipment transport over short distances. Its size and efficiency made it suitable for exactly these repetitive, low-intensity jobs that still required reliability. In mechanical terms, the longevity of the design reflects its conservative engineering approach. Systems were not overcomplicated, and components were built within operational stress limits that prioritized durability over peak performance. This meant that even after decades of use, many units could still operate effectively with routine maintenance and periodic part replacement. The influence of the design philosophy developed by Massey Ferguson can also be seen in later generations of agricultural equipment. The idea that a tractor should function as a multi-role platform rather than a single-purpose machine became a standard expectation in the industry. Modern utility tractors, regardless of brand, still reflect many of the principles embodied in the MF35: balanced power delivery, accessible maintenance, and adaptability across farm tasks. Economically, its impact is visible in how small and medium farms structure their equipment investments. Instead of relying on multiple specialized machines for every task, many operations prioritize versatile platforms that can handle a wide range of duties. This approach reduces capital costs and simplifies maintenance logistics, both of which remain critical in modern agriculture. Returning to a typical farm scene today, the contrast is clear. Where once manual labor and animal power defined the rhythm of work, A single operator with a utility tractor now manages processes that span planting, cultivation, and transport. The Massey Ferguson 35 represents one of the early and influential steps in that transformation. Its story concludes not with disappearance, but with integration into the background of agricultural life, where it continues to serve quietly, proving that in farming, longevity and usefulness often matter more than technological spectacle.